Previously. Hi everyone, welcome back to another devlog about making a C# game engine. I'm Alex, and today we're going to talk about Minecraft chunks, my possibly irrational hatred of entity component systems, and hacking the level editor that built Celeste. Let's get started. Last time, I went over how I built out an art pipeline with Sprite and the process of actually getting an image on screen in MonoGame. And while technically we could make the entire game in one long, horrible block of conditionals in our main loop of code here, it'd be nice to compartmentalize things a bit. We need a good way to represent all the characters in our game, so taking heavy inspiration from GameMaker, let's tackle actors. Our actor class is a massive catch-all for anything that needs to be created, updated, and drawn regularly, with these three events being represented as their own separate methods. The create method fires once and only once when they spawn in. For the object-oriented minded out there, this is effectively their constructor. It's where you chuck all the initialization logic that can't be made a compile time constant. Next is their update event, which is called once every frame. It handles the bulk of the actor's logic, things like movement, collision detection, anything which needs to be updated frequently. Finally, there's the draw event, which is called every time a frame is rendered to the screen. This is where all of our code to actually display the actor goes. On the back end, we'll also give each actor a name, position, and set of colliders. Not every actor will necessarily use all of these, but in general it saves us from constantly redefining variables and systems that are going to be common across different types of actors. Colliders are used for collision testing and can be square, circular, or basically whatever the hell you want. Every collider inherits from a base collider superclass where it individually implements how it tests against other colliders, allowing rectangles to bonk circles, lines to find polygons, etc. Of course, none of these actually exist right now beyond the glorious rectangle. There might be a day when we need these other collider types, but for now, it'd just be useless bloat. This is a pretty object-oriented approach to actors, with each type of actor having its own individual class, and that's intentional. I know there's a lot of very smart people out there proudly proclaiming the excellence of other patterns like data-driven design. That's where instead of thinking of actors as distinct bespoke entities like a Mario or a Goomba, you instead describe them with a series of smaller individual components, like a platformer character who can jump, shoot fireballs, and collect coins, and an enemy platformer character who can die. I find that unless you're making some crazy game with hundreds of permutations and connections, a lot of the time spent making everything data-driven is kind of over-engineering and future-proofing for issues you'll never actually hit. I have similar feelings about entity component systems too, but that's just an opinion. An unfounded opinion. Thanks for watching. Rants about the hypothetical data-driven bogeyman out of the way, we've got actors. Awesome! But uh-oh, they're just sitting in a black void of nothingness. Let's give them some levels to walk around in with tiles. Usually grouped into larger images called tile sets, tiles are tiny images, usually grid-based, which are placed around your level to make a variety of different environments. These were super popular and pretty much necessary in the 80s and 90s because cartridges had no space, consoles had no VRAM, and Mario can't do very much in a level that's only one screen wide. Though they're somewhat a result of hardware limitations, tiles are still commonly used in new releases. A big advantage of a tile-based approach is that when an artist makes a tile set, it lets everyone from programmers to level designers work directly on the look and layout of a level without having to constantly bounce back and forth to your artist because a ledge needs to be moved 4 meters to the left. It also means that if you want to change up the aesthetic of a level, edits to one image will populate across the entire thing. Tiles keep file sizes down and iteration times up. There's just one problem. It's a lot of draw calls to send to the GPU. Say our game's resolution is 256 by 224 pixels wide, and our tiles are 8 by 8 pixels wide. In total, that's almost 800 extra draw calls every frame just to draw the terrain. If we want multiple tile layers, yes, that number increases very quickly. And this is just one screen. Imagine what this would be like if you had to render an entire level. In my moment of pity for the GPU, I had an epiphany. Why not just tile tiles? Since new textures can be created on the fly, within reason, we could just create a texture, draw the tiles once onto that, and then draw that texture over and over again, like a giant tile. Say this texture is about half the size of one screen, and we suddenly cut our 500 draw calls per frame down to 500 once, and then like 4. By splitting up our tiles into larger chunks like this, like Minecraft chunks, sure, we get to take advantage of what would have been a benefit of keeping levels on one large texture, quick draw calls, while also having the upsides of tiled rendering, which would be speed, flexibility, and short iteration times. Hi everyone, future Alex here. Turns out I was a fucking idiot. All of this was wrong, or at least the way I implemented it was wrong. My implementation of this ended up being the root cause of a bug that has been tormenting me for 2 years! Where the game would randomly slow down to 20 FPS. I could not reproduce it. Turns out it was this stupid tile rendering system that I came up with that I thought was so smart. And generally what I said was still correct. I just, maybe don't create that many textures. This is looking more and more like an actual game, but there's a problem. It doesn't make sense to represent every image we want in a level as a tile set, because some of them won't be cleanly divisible by 8, 16, or whatever. We need some resource that basically represents a PNG. So I made a decal class for the backgrounds of levels and one-off larger static level objects which won't be frequently repeating. But pictures which just sit there are really boring. We need parallax, the thing that your eyes see when objects at different distances move at different speeds. But to do parallax, we need a camera system, and confession time, I was kind of a dipshit when I did my first pass at this. MonoGame's built-in sprite batch, the thingy which actually starts/ends a draw call, has an option to offset/transform everything it draws with a matrix. Fancy math word which means a bunch of numbers. Problem is, I hated matrices. My first stab at this camera system was taken right at the end of a semester's worth of linear algebra. If you've taken linear algebra, you might know where I'm coming from. The absolute last thing I wanted to think about over my summer was more stupid intersections, multiplication, translation, inversion. So I did what any other lazy bastard would do. In lieu of an actual camera system, I simply took the camera's X and Y positions, then subtracted that from whatever offset was passed into my wrapper for MonoGame's drawing functions. This eventually also started to shit the bed, surprise, surprise. So I later made a stopgap with a sort of view matrix, but fuck! This still sucks. Okay, quick confession, this series has been slightly out of order. I'm not a patient enough person to cleanly leap between topics like this, and I'm saying this now today because we're gonna break the rules a little bit, and I'm gonna go through and write a new camera system mid-script writing. Here we go. Okay, so somewhere in this giant camera class is the skeleton of a decent camera system, but it's been hacked a bit, so let's do a bit of refactoring. I'm sure there's hundreds of different ways you can think about what a camera should and shouldn't be responsible for, but none of my games are wildly complex. We can add fancier camera functionality if and when we cross that bridge. From the game's perspective, we want to be able to position, rotate, and zoom the camera in and out on a point. For me, this meant breaking a really old habit of having the camera's position be counted by its top left corner. It's much nicer to move a camera matrix around a center than its edge. Adding a bit of smoothing with linear interpolation, which is basically a game development cheat code, and it's done. Yeah, I thought the camera was going to be a much bigger pain in the ass. Oh god! Oh god! Oh dear god! Okay, camera sorted. Bim bam bosh. Where were we? Right, decals. So a static image is pretty boring, and with our nice new camera system, we can get some parallax in there. This can even be applied to foreground elements, which really gives the world a strong sense of depth and perspective. In summary, we've got actors who get updated regularly, responding to input, moving around the world, tiles and tile sets, which we use for making up the basic building blocks of our level's terrain, and decals, which represent mostly static sprites which usually act as one-off level elements or backgrounds. Now, how do we actually store all of this? We could write it out all by hand, but that would be stupid, shit, and terrible. Stealing a bit of film terminology, we're going to create a scene class. For our purposes, we can think of scenes as something like levels or maps or rooms. In a Mario game, you might have one scene to represent the title screen, individual scenes for individual levels, and separate scenes for the credits scroll and game over. Diving down a little deeper, for our purposes, a scene will need to store information about which actors, tiles, and decals are used, and where they're all placed. This is already much better than the mega loop from hell, but writing this all out by hand is a massive waste of time. We need a level editor, and this is something complex enough where I really shouldn't be reinventing the wheel. So, Tiled is super popular, and for good reason. Shovel Knight, Axiom Verge, and Carry On all use it as their level editors, and I actually used it for a while on a project you'll hear about in the next video, but I ended up moving on from it for a couple of reasons. Firstly, its handling of tile sets and how it embeds them in data wasn't my favorite. Parsing that data out of a .tmx and its associated tileset file, while not impossible, was kind of annoying. Secondly, I wasn't a fan of its workflow for defining actors. Everything was a gray box/polygon, which made distinguishing actors very difficult. While writing this, I found out that it's actually had the ability since 2018 to tie actors to art. Somehow my brain completely missed this. Oops. I also wasn't a fan of manually adding the properties for every actor whenever a new one was defined in code. So after our first release, which did use Tiled, I started looking elsewhere. It's a fantastic level editor, but just not the right tool for me specifically. Not quite as prevalent as Tiled, but what seems to be a growingly popular choice, LDTK is mildly insane in the amount of flexibility it gives you with how you want your level set up, along with providing a lot of nice quality of life features like auto-tiling, as well as lots of bells and whistles for how actors are defined and baked-in A-sprite loading support. But remember how we spent all this time talking about parallax earlier? Well, LDTK, at the time of looking at it, had no support for something analogous to our decals/any parallax image support or multiple background image layers. Easy, I thought, stupidly. It's open source. I can edit myself. I downloaded the source and proceeded to nearly bawl in frustration trying to get the damn thing to build. I love web technologies. Even after that point, I promptly stared at the source and noped the fuck out. The code wasn't poorly written, but inserting something as central as a new resource type that would change how levels are rendered into the editor was way beyond my reach at the time. If you're not a Celeste modder, I wouldn't be surprised if you've never heard of this one. It started out as Extremely OK Games' internal tool for making Celeste levels. It was eventually open sourced and then later ported to Hacks/Web Technologies to become the Community Edition. It doesn't have a lot of the fancy features of LDTK or Tiled, but when I'm wanting to parse the data it spits out or add new features, that's actually a bonus. I had a quick play around with it and, following my gut, cloned the source and decided that this would be my level editor of choice. So I'd settled on a level editor, but one that was pretty bare bones. So time to start making some tweaks and get this thing doing exactly what I need it to. Okay, time to get building, I foolishly thought, forgetting how much of an absolute pain in the ass hacks and node projects are to set up. After a lot of struggling, I managed to make the magical web technology stars align, install precisely the right versions of hacks and node to get compilation going, and finally start making changes. It's super pedantic, but I thought the editor could maybe use a tiny bit of a redesign, so let's overhaul this editor. What says aesthetic? What says cool? What says has a local concert in your area? This entire video, all the signs, they're all pointing to one thing. I've got to go to the Weezer. Why is my voice still echoing? That was pretty fucking great. I can't hear, and I think my voice is shot. No recording videos for a couple days. I think I learned a lot at that concert. Like the font choice. Much easier. Next, I wanted to get those parallax elements in. Having never touched hacks before, I fumbled around a lot in the source, bumping into things. Fortunately, Ogmo already had a decal class, so with a lot of trial and error, I was able to get some parallaxing level elements. Woohoo! Unfortunately, I did this in a mildly super terrible way, involving just redrawing the same image 100 times in each direction. Decals can be placed in a scene, and we can get a rough idea of what they'll look like in game. With the parallax preview sorted, I started ripping out stuff I didn't want and tweaking the stuff I was keeping. Goodbye. All these settings, we don't need them. Hello to hotkeys to cycle through entities. With that and some other small tweaks out of the way, it was time to tackle the big feature. The big feature was having the list of actors in the game and the list of actors present in Ogmo syncing up. An unsung benefit of engines like GameMaker, Unity, and Unreal is that things couple together nicely. If you create a new actor, you can easily place it in a room since it's all living under the same program roof thingy. Unfortunately, or fortunately depending who you ask, we're not GameMaker and we're using an external tool for level design. This means that the level editor has no idea who or what your actors are, and now you have to waste a fortnight defining all of them each time a new actor is added on the code side. Okay, remember how I mentioned not liking Tiled system for defining entities? This is why. Ogmo already has predefined stuff inside of it for defining entities and their associated data, how all that's represented, so modifying this would be a bit more invasive than adding some fields to something that already existed, like we did with the parallax. So here's the process. First, the editor gets pointed at the directory containing all our actor C# files. It then goes through and creates a corresponding actor representation on the editor side, but they're still all red squares. How do we actually tell all of these apart? Well, I gave this a good amount of thought and eventually settled on adding a metadata section to all the C# actor files, as this info had to be defined somewhere, and if all of the actor's behavior and other nonsense is defined in the C# file, this should be too. While setting up this metadata system, I also decided to throw in support for being able to define custom variables on individual actors. For example, if you want to set the direction an enemy is facing or what the text on signs should say, it's pretty easy to do. I also added an optional flag that would stop certain actors from appearing in the editor, for ones that should never be manually placed in a level accidentally. This was all topped off with the world's worst parser, which is honestly fine since this will only ever get run on development PCs very infrequently, and after wrestling with a bug where sprites just weren't loading, I love asynchronous processes, it was done, or as done as the level editor reasonably could be. Now, normally this is where I'd be wrapping up if I hadn't hit my final, for now, engine architectural snag. While working on a yet unannounced project. I wanted an enemy that could both interact with platforms and hurt the player. Doesn't this sound familiar? A lot of the time spent making everything data-driven is kind of over-engineering and future-proofing for issues you'll never actually hit. Maybe the Rustaceans knew something. Just kidding! Anyways, forgive me for my game maker tendencies, but with my older projects, the workflow there would be to give this enemy a generic enemy parent type so the player could check for collisions with it, and then call move scripts inside the child enemy if you wanted it to platform. Thing is, C# is statically typed, meaning you can't easily define variables on the fly like this, so I partially caved to my hatred of data-driven design and added a basic component system. This is less traditional data-driven design and more a thing I want to have act on an object? I'm not sure. Look, I made a platformer component which handles 2D platformer style movement and interactions with sloped terrain. Surprisingly annoying. Every actor that wants this 2D movement adds this component to a list, with the platformer component later taking care of the rest. Then all the actor needs to do is set its horizontal or vertical speed. This mildly flexible on a good day component system, which took some amount of brainpower, has been used exactly once. I don't know, maybe there'll be some more behavior sharing in the future that'll prove this system's usefulness, but for now, it's relegated to making sure that both the player and this log can roll up slopes. Ooh. On the engine side, that's pretty much it. To use a very unscientific measurement, we now have pretty much everything we need to remake the original Super Mario Bros. With the core engine development mostly wrapped up, we could finally start on our next ambitious project. A remake of a 4-year-old Game Jam game. Next time, the difficulties of expanding a team, the difficulties of reimagining something originally made in 48 hours, the difficulties of MonoGame not drawing levels on German laptops, true story, the difficulty...
Alex, you forgot audio. Alex, hey, it's me, Henry, the sound designer. The game has no audio. Alex, how will they hear my beautiful, beautiful sound?